Hi, everybody. I'm Evan Coopersmith. I'm the EVP of Data Science at AE Studio, and I will be the moderator of this panel this afternoon. I'm going to do a brief introduction and let my co-panelists introduce themselves. So I became a data scientist about 18 years ago because I wanted to write algorithms to predict the outcomes of baseball games so I could wager on them. And then this led me into a career in data science, which also led to co-founding a hedge fund in New York during the subprime collapse of 2008, so I have a good sense of timing, which then led me to become an environmental engineer and a government scientist in 2016 in the United States. So again, I have a good sense of timing. I then did professional analytics for a while and then joined AE Studio in tech in 2022 and 2023, so I have a good sense of timing. But right now I work for a data science development and design agency that is a completely bootstrapped and profitable business that builds any type of technology that increases human agency. Among those technologies and our big, hairy, audacious goal is brain-computer interface tech, which is part of the conversation we'll have today. And with that, I will let Jackie and Sumner introduce themselves.
Thanks, Evan. Hi, I'm Jackie Peters. I'm the founder and CEO of BlindInsight. We build encrypted computation and storage solutions that allow our users to store, query, and operate on fully encrypted data so they can get valuable insights from that data without revealing the data itself. I have a background in technology. I've been an engineer and a product person. So at this point, I kind of consider myself a highly technical product person.
Cool. Thanks, everybody, for coming. My name's Sumner Norman. I've been working in BCI, or neurotech of some flavor, for the past 12 years, despite my young appearance. I did research at Caltech for 6 years, where I developed a new neuroimaging technique, which I think we'll briefly touch on today. I was also chief neuroscientist at AE Studio for a couple of years when we were spinning up the BCI team. And now I'm a scientist at a group called Convergent Research. We're responsible, we're a nonprofit. We spin up large-scale, nonprofit, Series A style, very much a startup style, scientific research and development organizations to bridge the gap between academic style science and commercial style industry, bringing science projects along. So right now we're working on a large-scale neurotech project that we should be announcing later this year.
Perfect. And so I want to start the conversation off by saying that this is going to be a little bit beyond BCI and its potential for restoring human agency and whatnot. I want to cue this up by discussing the tension that exists with a lot of new technology, which is the sort of urgency with which we develop something that might benefit human beings, and on the other side of that ledger, the privacy risks that that sometimes poses. And I would like to implore everybody in the audience that we're sort of all part of this conversation, whether we're investors or whether we're researchers or we're just human beings with data inside and outside of our brains. So the question really will be, how does a society receive the benefits of these technologies, increase human agency in so doing, champion equality, and protect privacy? Which means we have to start asking some really hard questions about where we are and where we're headed. But before we do that, I think the most important thing we can do is ask Sumner the simple question. What is a BCI?
Well, by show of hands, how many of you actually heard of a BCI before? Okay, so pretty solid. But we're going to do a brief intro, and I'll show you a video as well. So this is an example of one of our patients at Caltech who was paralyzed from the neck down about 13 years before this video was taken. This was one of his first days in the lab. If you look closely, there's a couple of cables coming out of his head. Those cables are connected to electrodes, which are poking down into his motor cortex. We're recording those signals, interpreting his intention to move, and then recreating it with the robotic arm. In his particular example, we asked him what he'd want to do once he had this ability. And he's like, hey, man, I live with my mom, and every time I go to have a beer, she gives me a hard time about it. If I have a second one, she gives me a really hard time about it. So if I could just have a beer without catching shit for it. And so you'll see, he's pretty amped up by this. This was the first successful trial he had with this robot. But BCIs are relatively simple as a concept. So record information from the brain, take that information out using a computer algorithm, machine learning, to decode the intention, so correlating it to an intended behavior, and then from then on inferring what that person's intention is and recreating it with an external effector. That external effector can be anything. Cursor on a screen, here a robotic system, whatever you can imagine. That's sort of the easy part. That's my definition.
It's a perfect definition. And so the big, hairy, audacious goal of AE Studio is to build a brain-computer interface operating system and one that preserves agency for the human beings using them. I know a lot of you might be thinking to yourself, I would never have one of these devices inside my cranium. It's just not something I'm going to be comfortable with. And as my CEO is fond of saying, I believe you if you don't have a smartphone. And the reason he says this is, if I asked you the question 20 years ago, how many of you would sign up for a device that has a GPS system upon it that tracks your location, everything you've looked at, shopped for, and any number of other preferences? Oh, and by the way, this is going to be in your pocket every moment of every day of your professional and non-professional life. None of you would have been keen on that, except that none of you are capable of being professionals without a smartphone now. So before we are so quick to say that this is something that's going to be reserved for restoration and nothing more, I remind you, this would have been abhorrent to you 20 years ago, and I'm guessing, show of hands, anybody not have a smartphone? That's what I thought. Okay, so Sumner, what can BCI technology do at the moment?
Yeah, well, the line between restoration and augmentation is actually a much more fuzzy one than we like to give it credit for. So in Eric's example, and these are the types of things that BCIs can do today, the vast majority of them are motor neuroprosthetics. Your motor system is the most advanced BCI we could possibly imagine. It has millions of years of co-development or co-evolution with your brain to work so wonderfully. But in the case where it's damaged, and you no longer have that ability, a BCI starts to make sense. Anyone here could probably pick up that beer faster than Eric did with the robot arm and with a lot less effort. That takes a ton of concentration. That's where we're at today, motor neuroprosthetics. But as our interfaces get better, we can scale further across the brain. We can start to see multiple circuits and systems simultaneously, doing multiple things at the same time in parallel. Now we can start to address some of the things that start to get a bit fuzzier on that restoration augmentation line. So things like major forms of neuropsychiatric and cognitive disorders, major depression, anxiety, OCD, bipolar disorder. Those affect literally hundreds of millions of people who are both treatment resistant, meaning they've failed drugs of some type, and severe. So that is a lot of people who effectively the medical system we have today does nothing for them. But once you start treating a person with, let's say, major depression, then a person with moderate depression might say, well, hey, my friend is being treated. Why can't I? They're living a better quality of life than me. And who among us has not had, at least some burst of anxiety due to some life situation that we know wasn't actually serving us well? And in fact, a tiger isn't jumping out from the woods to kill us, but we're having that fear response anyway. So being able to turn those knobs at will is the sort of area where it starts to become gray. What is a disability and what is actually just augmentation?
Sure. And I can think of an augmentative example that I think will come at some point in the future. So I'm going to ask for a show of hands. How many of you have ever been sitting in a meeting and a thought unrelated to that meeting pops into your head that you feel the immediate urge to record, write down, take a note of at some point? It's now this distracting idea that you need to... Okay, right? And then how many of you have had the experience of, now I need to somehow surreptitiously get the note-taking app open, write down the note, oh no, I just lost the thread of whatever it is the person speaking was saying, and the note that I look at 3 hours later bears no resemblance to anything that I can recall. So I don't even know what the heck note I was supposed to be taking. So now I've lost 2 threads, both the current thread and the idea that I was trying to record. Now I offer you a device that allows you to seamlessly take that thought in your head, record it within its proper context, and retrieve it at a later point. How many of you want to buy that product? I think there's a pretty good market for this. Now recognize for a moment that in order for such a product to exist, there has to be something that has access to the intimacy of your thoughts and your neural data so that that thought can be recorded and later retrieved. Which means I'm going to point to Jackie and say, what exactly does that mean for us as human beings?
Right, thank you. So what more sensitive data is there really than the data that our own brains generate, right? You can lie on a form, you can, mislead people when you're talking to them. It's pretty hard to lie in your thoughts. And so the data genie's out of the bottle, right? Our data's all over the place. Show of hands, how many people have been notified they've been affected by a data breach? What about...
The rest of you will be getting emails shortly.
Yep. How many people have had their identity stolen? Fewer people. About a third of people in the US actually have had their identity stolen.
They've got something going here in Canada. That's pretty good.
And so, I think that to a large extent, a lot of folks are sort of jaded to this. They sort of simply accept it as the price of living life and doing business in a connected world. But the question is, how would you feel if your thoughts, your feelings, your emotions were exposed, stolen, or worse, used to manipulate your behavior? So regulators and tech companies are all sort of scrambling to, put the cork back on the bottle when it comes to our data, but it's already out there, right? And so, is there anything we can do about this? We're not sure. I'm hoping the technology we're building can help. But it's not too late for BCI data. BCI is pretty early days, and so I think that brings us to this conversation.
Yeah, and it really is nascent. So we have a kind of incredible opportunity in front of us that the data standards that are being implemented aren't finalized yet. People are still trying to figure that out. The types of regulatory guidelines, guardrails that should be put in place are still being figured out. It's probably too early to be putting full-on regulatory environments in place, and we're lucky that right now at least, the majority of really effective BCIs like Eric's are invasive, which means they have to go through a surgery, which means they're subject to every law, whatever jurisdiction you're in, that any medical device would be, any implanted medical device. And so right now, they're sort of adopting those environments. But as they become more and more capable, and the software becomes more capable, how does that change? And in fact, where you really see a step change in my mind is that we've all seen with recent advances in AI and ChatGPT and so forth, that training a large language model or an image recognition model, those networks require absolute incredible amounts of data, corpuses that are just like boggle the mind. But you can go scrape the internet for any number of images that people have uploaded to create an image recognition. You can go scrape the internet for natural language across every forum that's ever existed. What you can't do is jump on the internet and scrape terabytes and terabytes or exabytes of patient brain data. Because right now, a lot of, like as I said, is a good thing that a lot of that is protected, or best case, it's de-identified and shared, but usually in small amounts. You're very rarely going to actually look at the raw data. Part of that's just because it's really big. And that's with today's neural interfaces that will continue to grow. And that's where actually a lot of these data privacy techniques are not actually inhibiting our ability to share, but actually could allow us to share. Because if you can create a data privacy environment in which you can start to share that patient data, now you can actually get it out to researchers that are building these complicated models. Frankly, the ML, the machine learning, is light years ahead. We have these models that are incredibly complicated and able to do incredible things, but we can't train them because we simply don't have enough data. We ran into this AE again and again and again, that we knew how to solve a problem, but actually gathering the data was the hard part. If there were better ways of sharing that in environments where you actually persist through those data privacy modules, then now you can actually train these models and do really great things with BCI, but that's missing right now.
Mm-hmm.
Yeah, and so we're talking a little bit about data and the challenges with measurement. I briefly alluded to this. My doctoral and postdoctoral work had nothing to do with neuroscience. I was a soil moisture hydrologist, which basically means the math problem for which I was responsible was telling how wet and dry the ground is anywhere in the world. And I was always fond of saying the most complicated data set in the world is the world. Sumner has corrected me and told me, in fact, I'm wrong, that the most complicated data set in the world is the brain. And he's right, but there's an isomorph in this problem, which is, how do you measure how wet or dry the ground is? It's easy. You dig a hole and you stick a sensor in the ground and you get a reading. Low-tech science. Except for the fact that the world is too large and complicated and heterogeneous for that solution to be of any value at scale, right? With all the heterogeneity of textures and topographies and vegetation covers and the vicissitudes of precipitation, you're never going to be able to measure enough in enough places. So you measure in a handful of places, and then you have to build machine learning models to connect the dots. In the same way that you can't measure the traffic at every intersection in a major city, but you might be able to measure in some key locations and then build some connective tissue mathematically. The brain creates a similar kind of paradigm, and I was hoping Sumner could give us a sense of what we can and can't measure when it comes to the brain.
Yeah, to give you a rough sense of scale, the brain is about 80 billion neurons with about 1,000 synapses between every neuron. And between each of those synapses carries some amount of information. You can think of it almost like the binary code. It's either firing or it's not, in the same way that a transistor on a chip is going to do that same thing. So that is an incredible amount of data throughput. There's been many estimates to what that actually looks like, but all of them are very big. Sampling, that's really hard. As we've talked about just a moment ago, the ultimate value of a BCI is your ability to interpret that data as it streams in live form. So you can either, to get access to that data, you either get more bandwidth out of the existing devices, or you put that device in many, many people. And you basically multiply those two things together, and that's the raw amount of data you have to train these models. The more data you have, the more complicated the models, the better results you get. So you can create more complicated hardware. That's going to get you some more bandwidth, but sampling 80 billion neurons simultaneously, or the 1,000 connections between those, is almost infeasible, maybe not in the long run though. And so we can talk a little bit about what that means, or the other side of this equation is getting it to more people, making those devices less invasive or non-invasive, more accessible, cheaper, higher throughput. Basically, it's the multiplication of those two things that the field is grappling with right now.
Right, and so if you've given us a sense of where the challenges lie, and it's fundamentally whether it's soil moisture or neurons, there's a sampling problem. What is ultimately going to be the solution that addresses it?
Yeah, we're kind of struggling with that now because we have about 100 years of history in the BCI field of electrophysiology. This goes all the way actually back to the 1700s when Luigi Galvani was like stimulating dead frog legs with, I see someone laughing, but it's true that this is the oldest thing that we know about the human body and specifically how the brain works is through electrophysiology. In the 1960s, people started measuring that, and actually back to the 1920s, people were creating electroencephalography, so basically measuring brain waves, but this is the kind of summed activity of millions of neurons working together, so it's kind of low resolution. And then we started sticking electrodes into the brain, as you saw there with Eric. We started doing that as early as 2001, I think was the first human intracortical electrode arrays that we had put in. And so those are now sampling about a couple hundred neurons at a time. But as we scale, we run into this problem that putting those electrodes in, just by nature of it going into the brain itself, it damages neurons as it goes. So you kill a couple hundred neurons to record from every one. Now you might get that down, but in fact, if you want to record from the whole brain, you need to get that down to 0. So we're kind of starting to go back to the drawing board, and we're seeing this a lot in the field. And this is what my work at Caltech was doing, was a part of this, is what are the next generation of sensing modalities? What biophysics allow us to measure the brain? Optics and acoustics are really both quite good for this. They're both active sensing techniques in that you put light into the brain and you record how much of that light, how many of those photons actually make it back. Turns out there are biophysical effects that when a particular area of the brain is active, it starts absorbing some of those photons more than otherwise. So you can infer from how much light is scattered if you're measuring a change in the brain. Similarly with acoustics, we can actually measure how many red blood cells are traveling to perfuse neurons that are using metabolic resources like oxygen. You can start to combine those engineering techniques with biomolecular techniques, actually gene therapies to start creating calcium indicators, all sorts of really fancy stuff, but all of this is happening remotely, so you don't even touch the brain. You just send energy in and record energy out. And that's where the next generation is coming. So we all hear about Neuralink in the news, and that's exciting because it's going to take things like we saw with Eric and give it to potentially thousands, hundreds of thousands of people, but will ultimately be somewhat limited in the indications that it can address because you can't scale those electrodes across the brain. So vision, motor, the things that are kind of highly localized, smaller areas in the brain that we understand quite well, it'll do that really well. But as we start to get into cases of mental disorders, neuropsychiatric and cognitive disorders, I think it's these next generation of interfaces that are really going to kind of blow the doors open on the whole thing.
And to your point, when the doors are blown open in that regard, and we're talking about something as sensitive as mental health, and it becomes scaled, and this becomes more and increasingly ubiquitous, the privacy concerns begin to rear their heads in any number of obvious ways. And so I'm going to, again, turn to Jackie and say, what do we do about this? Because this is going to be part of our lives one way or the other.
Yeah, we're about to get an awful lot of very sensitive data, aren't we?
Yes.
And so I think it's clear that BCI needs a privacy layer. And this probably shouldn't be left to regulators in the 11th hour. It should be built in. There should be privacy by design, and I think the industry can really take that responsibility and is taking that responsibility. I'm very happy to be working with a studio. And tracking individuals at the level of thought is a scary proposition. It's a huge, huge privacy violation, and yet it not only is not very far away, it's here. So companies that everybody's familiar with are underway with programs to place EEG and other devices on their employees' heads so that they can keep track of what they're doing. This is already happening in China. Several companies have been doing this since 2018 in China. And so imagine that your boss has the ability to, in real time, determine your level of attention, what you're paying attention to, and even conduct sentiment analysis on your thoughts. And so this is actually happening. It's not some dystopian Black Mirror-like future. It's starting to happen today. And what happens when Meta Corporation has a direct jack into your brain? They're already using hijacking our dopamine, right, to influence our behavior. And so if this is something that they are able to do, I have no doubt that they're going to do it. And then what happens when they start doing that with our children, right? Our kids have an EEG headset to play games with their brains on Facebook, and at the same time, Facebook is tracking everything they're doing and thinking and then using that data to manipulate them. So that's pretty scary. And then there's also a world where neural cyber attacks are possible, right? So a hacker or even an AI can hack into a device that's implanted in your brain or that you're wearing on your head and basically enter you into a master-slave relationship. It sounds crazy, yes. Sorry to be the hard. I was telling these guys, I'm like, oh, like my part of this is pretty dark, actually. But this is all very real and very possible, and in our lifetimes. And so, what are we going to do about it, right? So, adding a privacy layer to BCI today can really help us avoid a lot of those really scary situations. It also can help speed up research, right? BCI suffers from small data sets. Sumner has referred to that, and so it can really help researchers share and have access to larger, higher quality data sets. It can help software engineers build applications for end users that are able to maintain individual privacy and security.
Yeah, and you hit on a point that I wanted to emphasize, which was around regulations, that some will immediately call to regulations. But that's tricky because you really need to provide guardrails without providing roadblocks. You don't want to stop the technology dead. And historically, with new types of technology like this, we've gotten this wrong, especially when we've regulated early. The tech is super nascent right now, so despite what Elon might have you believe, it's probably far too early to start thinking about direct BCI specific regulations beyond what's already there in the medical spaces. And I mentioned this earlier, but I'll mention again, hundreds of millions of people suffer from these neuropsychiatric and cognitive disorders that have no recourse whatsoever. And so there is a real, very real cost to that continued human suffering if you slow the technology down that could help them. So there is a balance here between you want to make sure that you differentially drive the good parts of the technology forward as fast and as efficiently as you can, while not doing it so recklessly that you actually overlook a privacy layer or somehow create a version of the technology that's used for bad.
And it becomes a question of balance that's difficult to frame, right? Because if I'm an individual suffering from any number of neurological disorders where there, as to Sumner's point, there isn't any recourse, I'm going to be rather irritated at anything that means relief of my suffering is somehow delayed. And yet, if I'm somebody who values my own privacy, which I think probably all of us do, we would find ourselves rather frustrated and irritated if somebody was not considering what that would mean for our future. And once, sort of to your point, the genie's out of the bottle, there's no ability to reverse course after the fact. So how do we sort of walk that line? How do we thread that needle?
Yep. Yeah. So, totally agree. We need to, move this technology along as quickly and as safely as we can. BCI suffers from small data sets because there are so few devices in the field. Privacy regulations make a lot of sense. They protect individuals, but they also slow research, right? And so I think putting up those guardrails ahead of regulations is really key. And unfortunately, a lot of healthcare organizations move pretty slowly. Yeah. And so especially when it comes to adopting new security solutions, and which means that everything else happens more slowly. Technological innovation happens more slowly. Care delivery happens more slowly. Research and development happen more slowly. And so I think, this is sort of a call for, corporate and institutional innovation, to really answer this challenge and to start working with these technologies now so that they can be vetted, validated, and, start adding value to the ecosystem today.
And institutional incentives are complicated, right? Because we have private sector incentives, we have academic incentives, we have sort of incentives on the part of a patient, a user, society as a whole, and these things are sort of all in some regards, I don't want to say at odds with each other, but they create this sort of very complicated and often muddled picture. But I want to think a little bit about how scientific progress and technological progress tends to occur. Quick show of hands, and I realize I'm geeking out a little bit here. How many of you have read Thomas Kuhn's The Structure of Scientific Revolutions? Got a few. Okay, at least there's a couple of hands that have shown up, so I don't feel completely alone here. So this book was written about 60 years ago, and I think it's aged spectacularly well when you look at its sort of conclusions through the lens of history. And the argument that it makes, summarizing a longer piece of writing, is that progress doesn't occur incrementally, nor from the accumulation of knowledge and experimental results, But it's this sort of episodic paradigm shift that occurs. And they use as an example, 100 plus years ago, plate tectonics was considered basically pseudoscience. And then comes that rather dark phrase that progress occurs one funeral at a time. The old guard of academia passes off, and then the next group has a different paradigm of the world. Who knows what we will think of string theory in 50 years? Maybe there will be some paradigm shift and we'll look back not so fondly at the current day, or maybe we'll find a theory of everything that way. BCI is another one of these examples where this sort of doesn't occur in a nice linear fashion. It sort of comes in fits and starts where these external voices and different influences sort of push us along in fits and jumps. And Sumner, can you give us sort of a sense of the history and where we might sort of jump ahead?
Yeah, I kind of started on that, I guess, on accident already, which was we started the stimulating dead frogs. That was pretty fun. In the 1960s, started actually stimulating large animals. There's a really great video of Jose Delgado, a Spanish scientist, that put an electrical stimulator in a bowl, and the bowl's charging him, and he just presses the button, and the bowl stops. And so, kind of early examples. And so people even then were having these conversations, and they were probably a little bit early. And that's because he's an excellent showman. And so that leads to the question, are we in an era of real growth in technology, or are we in an era of excellent showmanship? And I do think we're kind of on the cusp between those two things. So we have to be careful, and to be honest, I'm really quite nervous about it. So I came into the field in 2011, and no one was really talking about BCI as much. It was sort of a niche thing, even within the academic community. People weren't really sure what it was certain to work for and how you would actually scale it in any kind of commercial sense. Now we're seeing a lot of interest, we're seeing a lot of funding. Then Elon Musk coming into the space and starting Neuralink really ramped that up, caused a kind of shoulder on that exponential curve that many people didn't expect. But hardware is expensive, it's risky, it's really slow compared to software. So you're talking about making advances that can take a decade or more to go from the advent of the idea to actually putting that device in a human, especially if it's invasive, right? So as I mentioned earlier, now we're moving beyond electrophysiology. So we're starting to move into a whole other era of biophysics. And I think that that's actually the real revolution that's kind of hiding behind a lot of the hype that you don't hear about, is that when I started in 2011, that was it. It was electrophysiology, and there's a few groups talking about near-infrared spectroscopy, but it was pretty rare to come by, frankly. Now, all of the frontiers of BCI, there's probably 50 different methods out there that people are poking and prodding, and I'm responsible for one of them, not all 50. But what I do worry about is in the short term, fickle is the nature of the public masses. If you have everyone gets so excited about wild claims about what basic electrophysiology could do when scaled at commercial level, if it doesn't meet that promise and investor interests start to walk away, they go, BCI, it doesn't work. When in fact, behind it right now, coming out of DARPA and many academic labs and new sort of nonprofit style startups and things like that, all of these new technologies are sort of running into the space with entirely new ways of sensing the brain. So I don't know if the current push sustains that all the way to a commercial product, or if you have a giant bubble that pops and we have to wait another 20 years before people pick up the pieces. That happened once sort of already in BCI. We saw it in AI. There was a big jump in neural networks in the 90s, and everyone thought that was the big one, and then it kind of popped. And then we waited almost 25 years before we had the now current push of AI. And this one seems to be the one that has real-world commercial utility. So I don't know.
Right. And speaking of the jump forward, it's hard to talk about any type of data-driven technology without talking about AI these days. And certainly we can think about what LLMs have done and their ubiquity. I don't know that any of us were talking about them a couple of years ago, and now suddenly they're anywhere and everywhere. But that sort of raises a whole new set of questions, right? So in Europe right now, there's a debate as to whether large language models are going to run afoul of GDPR because they're going to be trained to some extent on what would be personal individual data. Okay, so there's going to be a challenge with the technology from a privacy standpoint, except just as it's essentially impossible to be a professional without one of these, does anybody imagine they're going to be able to function professionally in 5 years or 10 without LLMs being part of their workflow to some extent? I can't imagine, right? How many of you use LLMs right now, daily in your, right, okay. And this has been around for an hour and a half, and it's already half the room. Anybody think you're going to escape this? How many of you think you will be using LLMs in your workflow 2 years from now? 5 years from now? Anybody doubt you'll be using them in 10? Okay. So one way or another, we're going to be grappling with this. And what are we going to do? Are there going to be concessions made in different parts of the world? Are we going to have regulations to which every jurisdiction and every nation is going to adhere? I doubt it. Is that just going to mean we're going to make another sacrifice with respect to personal privacy in the same way this made us make a few concessions that we're just not going to give back, and we're all going to sort of get accustomed to it at a certain point?
Yep. Yeah. So you're probably aware Italy had banned ChatGPT because it violated GDPR. Several private organizations, Apple has prohibited its employees from using it because they have privacy concerns. So again, having a privacy layer in the middle where you can get valuable insights from all of the sensitive data without revealing the data itself is really, I think, going to be required to be able to progress in a positive way.
So let's think a little bit about the future and put on a lens with different ranges of time. So let's think about human values 1,000 years ago. Human values 1,000 years ago included things like probably child sacrifice, probably included slavery. I can't imagine our views of any minority group that wasn't our own personal tribe was particularly favorable. Does anybody here think that human values were even remotely acceptable 1,000 years ago? I can't imagine, right? Now think about human values 100 years ago. So that would have been in the United States, where I'm from, that would have been the segregated South. In Europe, that would have been the precursors to the Holocaust. We don't have a particularly favorable view of human values 100 years ago. We weren't even thinking about smartphone technology 20 years ago. We weren't thinking about LLMs 2 years ago. Notice that the time frames continue to compress. What will we think of LLM technology in 2 years? What will we think of BCI technology in 20? And what will our descendants 100 or 1,000 years from now ultimately think of our views and our values and our place in history? And remember for a moment that there's probably never been a point in history where we had a favorable view of our values 100 or 1,000 years before. So just think about that as you think about what people will think of us in 100 or 1,000 years. So where does this all lead for us?
Oh, I hope you don't want me to actually answer that question.
No, I'm just kidding.
That's impossible.
This is what I do. I ask impossible questions and I ask him. This is easy. I have the easiest job in the room.
Yeah, I mean, I don't know, but obviously, but I would be really interested in hearing from a lot of folks here what they think.
Yeah.
I've sort of been on a world tour for this recently. I was in London last week with some of the folks from OpenAI and a bunch of folks from the neurotech field trying to figure out how do you instill human values into an AI system, align that system to actually carrying those out in a way that doesn't run off the rails, especially when you start scaling those systems to the level of superintelligence or artificial general intelligence, AGI. Which can seem like a far-flung problem, but these days most people are starting to adjust to the idea this could be very much a near-term problem. Some people think, and I'm still on the fence here, frankly, that neurotech could be used for that. Neuralink, founded in 2016, so ahead of its time in some ways, was thinking about this. They talked about using a neural interface as almost a tertiary cortex by which to communicate better with AI, to make effectively super intelligent humans. It's an augmentation play, right? There's also many other ways of doing this, putting humans in the loop. So as AI is making decisions or training, you have reinforcement learning with human feedback. You could have reinforcement learning with brain feedback, which is almost a much more automatable, scalable way of doing it. You can record large corpuses of data to create generative models of humans that instill those human values in an automated way in silico, so you don't even need a human in the loop. So a lot of people are thinking about how to use neurotech for these approaches. We don't know if any of those will actually work, just to be totally clear. These are very much like out there scientific ideas. But the field is really starting to roadmap. How do you kind of poke all of those and figure out which one of them holds promise, if any? And we'll see. I don't know. We'll find out. But hopefully, if we can meaningfully contribute from the neurotech space to the AI space, we would love to. That's how AI got started, in fact, was looking at neural networks, right?
Sure. And so you build this representative model of a human brain, and then everybody's human brain is to some extent distinct, but in aggregate, there's some sort of like composite view that allows us to create this brain-based feedback that you allude to. So now the question is, does that answer privacy concerns where it's not any individual brain, but it's some sort of broader aggregation of collectively how brains view something as ethical or not?
Right.
Is that kosher or is it?
I mean, I think, is it kosher for me? Maybe. Is it kosher for regulators? I think no, right? So the reason that ChatGPT was banned in Italy is because they scrape people's freely available personal information from the internet, which is not allowed according to GDPR, right? And so I think there will continue to be issues around privacy, And I'm really hoping that privacy-enhancing technologies will ultimately be a valuable piece in the tech stack, both for BCI and for AI, and make the difference between a potentially dystopian future and world-changing progress, right? And so that's really the hope, that we can use this technology to help strike a balance between protecting individuals' privacy, adhering to privacy regulations, and also accelerating research, development, technological innovation, and delivery of care. So that would be a win-win, I think, for everybody. Mm-hmm.
Well, thank you so much for indulging us and this sort of twisting and serpentine path. So I think at this point, if anybody has any questions, we'd love to hear from you. So thank you so very much, guys.
Thank you. Let's go here and then back there.
Thank you. Like on a scale of 1 to 100, where is the current knowledge bank on the utility of the brain, the anatomical and physiological utility of the brain? Are we at a 1 out of 100 or are we at a 90 out of 100?
Maybe a 10. Like the motor system is so well defined. I can tell you exactly where it's at in your brain. I can tell you the topology of it. Some of those cortical spinal cells are actually monosynaptically, meaning a single connection connected to motor neuronal pools. So it's a very simple system. So when you see these demos, it can be very impressive, but that's because it's from a systems neuroscience area that is really well understood. Same thing for vision. Vision is kind of monosynaptically connected, or at least disynaptically connected to retinal neurons. And so those ones are quite tractable, but frankly, we know so little about the things that make us most intrinsically humans, things like values, unfortunately, things like depression. And so I think we're a long ways off there, so maybe a 10, best case.
Hi, I was just wondering, going back to when you were talking about acoustics and looking at blood cells, I was just wondering, with the connection to neuroscience, has there been any just thought of looking further into musical training and the differences between people who start early in life and later in life, and how that could help the cognitive perspective?
Yeah, so I'm hearing a couple questions in there. One is a developmental neuroscience question. One is specifically around music and acoustics, and the other one is around the neural interfaces themselves. Yes, people are thinking about all of those, mostly separately at the moment. One thing I will say, and I'm actually glad you kind of brought up these other more behavioral paradigms of therapy. Neurotech alone is kind of useless without some type of behavior. So this is one example of something that could become a cognitive behavioral therapy that might be really high efficacy for certain indications. We don't know. That's what's being discovered. But the fact is, what neural interfaces can buy you is a couple things. One, neurofeedback. So you can give people access to understanding how their brain's working in real time and let them adapt their own brain function to be better for whatever thing they're trying to achieve. But that requires behavior, which is the therapy. This is also true even in motor therapeutics. So I came from stroke research, where we were actually using exoskeleton robotics to help people move that couldn't normally move. But the number one thing that predicts a person's success is their ability to sense movement and their motivation, effectively. How motivated are they to actually do this? How many repetitions will they put in, and how hard do they try? And you can use neurofeedback to amplify that effect, but either one of those things is less effective than both of them. So it's actually the combination of behavior and neuro that are most exciting.
Thanks for the talk. Beyond just a layer of individual privacy, I want to know your guys' thoughts in terms of responsibility from a company's perspective in being open and doing open source, open science of what they're actually doing with the data and how they're actually altering data and or doing any of the algorithmic level, knowing that that might be at odds with what VCs might say. And coming from a neurotech startup and a BCI background myself, it's one of those things that we hear all the time.
Do you want to actually handle that from a BCI perspective?
Yeah, to be totally clear, like at AE Studio, it was a big part of our roadmap is that we open sourced almost everything that we could. Basically anything that a company would allow us to that we were working with, and then everything we did on our own, which was about 50 to 60% of our work, we open sourced. So it's all out there for the world. We're big believers in basically the Linux model. System, in this case an operating system, so quite similar, that is developed for and by the users that are eventually in the community that's going to create it. And if you want to build a company on that, like I think you can convince VCs that Red Hat-like models, where you are the world expert because you are the main contributor and supporter of that open source code, you are going to be the most effective one to build specific instantiations for companies that need to moat that IP. There are a few kind of edge case exceptions where gain of function can actually be dangerous. We see this in AI already, so this is people's main criticism of OpenAI is like, why are you putting this out there if in fact you're basically touting gain of function and creating more risk when in your mission statement you want to create responsible AI. Now I'm not saying like I'm specifically for or against that, but you could make a specific argument for the same thing for BCI. If you create a dangerous form of BCI that opens up data privacy and splits it open, then like maybe you shouldn't be putting that in the open source code. Although it might be useful in some limited scientific setting, I don't know. So there are niche cases, but for the most part, we're very much down for open source.
Yeah, and do we always know, right, what's going to be dangerous and what's not? Right?
Yeah, that's hard.
And I think in terms of a security product, it needs to be audible, right, auditable. So, from our perspective, we plan on open sourcing, all of our encryption, algorithms, and basically anything that's not part of our SaaS application, so that it can be audited and people can trust that it's actually secure. Yeah.
Cool.
Right.
All right.
I think there's one question.
One more.
There's a hand in the back that I see.
You were talking about the privacy layers. I was just wondering, when you're doing studies in psychology and sociology, there's an ethics board, and we follow a really long list of ethics guidelines. In AI, I know that it's very complicated, and it's not really a clear standard structure. What would an ethics guideline that would benefit you guys the most look for you?
I'll take a shot at this on a couple of levels because to your point, right, there isn't an IRB for building artificial intelligence algorithms. And so one of the things that is sort of an interesting precept to think a little bit about is if you're going to do something that might enhance capabilities in some regard, to do so with a rather limited amount of computational power unless you have some evidence and some way to show mathematically that even if you enhance those capabilities, you don't create an alignment risk. So I'll give you an example. One of the things that we're doing at AE Studio is taking a look at models of attention as it relates to AGI. So just as there's sort of bottom-up attention as an algorithm responds to stimuli, whether that's pixels forming a convolution or whether that's individual words feeding a transformer, there's also what humans do, which is sort of a top-down version of attention, right? Where we deploy our attention to various things. I can look at you, I can listen to the people next to me, I can look at those lights, and then there's sort of a model of my own attention, and I have a model of your attention too, and this leads to some amount of prosociality and empathy. And we're very interested in this idea as it relates to artificial intelligence, and we're doing some research on it at AE Studio right now. What we've noticed, though, is that using tools of this nature sometimes improves the rate at which AI algorithms are trained. Now, on the one hand, this is really exciting. Training an algorithm more efficiently and faster, fantastic. For financial insight, right? This is a good way to build a tool that you can use. But you're not going to turn up the GPU usage and anything like that until you've demonstrated that when you have multiple agents using algorithms of this type that interact with each other, that their equilibrium strategies are more pro-social than they might otherwise be. So that's one way to think about it, which is before you sort of release the torrent of GPU and processing power, you do the exploration of how multiple algorithms of this type might engage. There are no good answers to this question, right? Everybody's trying to figure that out in real time, but it's a fantastic and important question. Right? Anybody else?
All right.
Looking around the room. Thank you so much. Or
Thank
was
you.
there another question? Okay.
Okay.
I saw you
Thank
walking.
you, everybody.
Thanks,
everyone.
Thanks.